Hello everyone, welcome back to my channel, and today we are going to learn the another topic of our um, first chapter, that is your topic number one. So today's our subtopic would be the isotopes. So it's quite an easy topic, it's not tough at all, easy to understand, easy to answer the questions related to isotopes. So what are the isotopes? Isotopes are basically defined as the atoms of same elements which have the same proton number. So these words need to be like memorized. These are very important words when you write the definition or when you want to explain the isotopes. And different number of neutrons or the different atomic mass or the different mass number. So these two things are very important to mention. First is the proton number, second is the neutron number. Same proton, different neutrons. For example, if we talk about the hydrogen has three isotopes: protium, deuterium, and tritium. Let's have a look at this. Now look at this hydrogen one. It has one proton, but there is zero neutron. Clear? In deuterium, we have one proton and one electron, a neutron. In tritium, we have one proton but two neutron. Now, if you carefully look at this, you can easily see that the number of proton is not changing. It's one in protium, deuterium, and tritium. But if you look at the neutron number, the number is different. Here we have zero neutrons. In deuterium, we have only one neutron, but in tritium, we have two neutrons with one proton. So this is how you explain or define the isotopes. Sorry. Isotopes are different because they have different number of neutron. It means their physical properties can be different. If there are more number of neutrons, it means the atom is heavy. The density could be different because of its mass. So it was first discovered by Soddy. Like carbon has two isotopes: carbon 12, carbon 13, carbon 14, and we know that carbon 14 is extensively used in carbon dating to know the age of the ancient bodies, so or the rocks. We use C14. There are almost 280 natural isotopes. There are 300 artificial isotopes. So most of the radioactive elements, those all are the isotopic one and the artificial isotopes that we made. So what are the interesting facts? Number one is the isotope of elements with even atomic number or more as compared to the odd number. For example, the oxygen, nickel, calcium, these all are even one. They have more number of isotopes, while the odd atomic numbers have less isotopes. The monoisotopic elements are arsenic, gold, fluorine, and iodine, means there are no isotopes. So what is the method that is used to determine the mass of an isotope? You are going to learn this in organic chemistry as well, when we want to know the mass of a certain compound, and here also. So there is a technique called as the mass spectrometry. So it is a study in which the mass spectrometer is used to measure the exact masses of isotopes. It has general four steps that we need to follow, and it separates the atoms or the isotopes with different masses. So it's an instrument, and there are two type of instrument that are commonly used. First is Aston and second is a Dempster. We commonly use Dempster's one. This is how it looks like. It's quite a bigger machine because it has certain parts. Let's look at those parts. What are the parts? Number one is the volatile. We make volatiles. We make a gaseous form of any substance, whether it's a liquid, it's a solid, or it's a gas. We have to convert it into a gaseous form. Why? Because further on we have to remove the electron. So it should be the separate one. The electrons, the atoms or the particles should not be joined together. They needs to be separate. That's why they are first converted into gas. Then second one, they are ionized. The electron is removed so that they can move in different fields. They pass through the magnetic field, and then they are separated on the basis of mass to charge ratio. And then we further have the results in the form of our spectrograph. So first of all, how it works: there is a gaseous sample that is inserted into our machine. So first of all, it gets vaporizes, means the if it's solid or a liquid, it has to be converted into a gaseous form. Then a beam of electron source is bombarded to convert the gaseous form into ionized form. Then the ions are accelerated by passing it through a certain plates, and then it pass through the magnetic field, which actually divert which actually take different paths, and the electron for us, or the atom, or any other molecule, whatever sample we are taking, they fall on different atom 1, atom 2, atom 3, whatever, they fall onto different one. Then the result is amplified and recorded. So these peaks, they give us the value of the masses. Let's look at the result. This is a spectrograph. Now here we have peaks: peak number 1, peak number 2, and peak number 3. Clear? Now look at this peak. This has shown the highest value. Let's say the abundance is 90%. So the isotope with 20 AMU, or the whatever the mass is, let's say 20 mass, it has the highest percentage, or in like existence. The 21 has only 0.20%, while the 22 one is 8.82%. Now we'll use these results to calculate the average or the relative atomic mass of a certain atom. So we'll do this in the next video. Let's calculate in the next videos. Stay tuned.